This is Chemistry Equilibrium, Homework Problem 31, Chapter 14. Now, in this case, we're given a reaction N2O4 to 2NO2, both of them gases, gas and gas, and they do give the equilibrium constant here, and that's at 500 Kelvin. The constant is 0.513. Now, they're giving you an initial concentration here at the beginning, and then it's going to stabilize. They're asking, what are the equilibrium concentrations of both of these at 500 Kelvin? Now, they don't actually mention, but in this case, yeah, this is just 0. There's nothing there at the beginning. So, just like before, we need to set up an ICE table. So, we're going to set up the ICE table. ICE, and we'll just go ahead and write these down here. N2O4 and 2NO2. 2NO2. Now, initially, we have this value, 0.0500, and we have the value here, which is 0. Now we need to put the change here. The change, because this has a coefficient of 1, it's minus 1x. And for this one, it's plus 2, because there's a 2 here. So plus 2x. Now we sum this up for the equilibrium, and we say that is equal to 0.05 minus x. And this is 0 plus 2x, which just gives you 2x. Now, what we need to do is write the equilibrium constant equation and put these in there. So the equilibrium constant equation, Kc is equal to, in this case the number is given, so I'm just going to go ahead and write that down. I don't know if it's actually needed yet, but we'll see. 0.513, and that equals the products, which are over here. It's a concentration of NO2, and the coefficient is 2. So we actually put that 2 over here as a power, 2, and we'll put this as the reactant, the concentration of N2O4. Notice we don't actually have any values, but we do have these equations. So we're going to plug in the equations and work them out. So the equation for NO2 is 2x. So we're going to put 2x in parentheses, and we're going to square both of them, square it. And then N2O4, which we get from here, just write it down here. 0.05 minus x. And remember, that whole thing is equal to 0.513. Now, right away, let's go ahead and simplify this guy here. So that equals 2 squared times x squared, which is the same thing as 2 times 2 is 4 times x squared. Now I'm just going to rewrite this whole thing down here so we can actually work it. So we have 4x squared, which is this up here. That's the products, the numerator, over 0.05 minus x. And that equals 0.513. Now we're going to multiply this bottom piece down here. We're going to grab this piece down here, and we're going to multiply left and right sides with it. What's going to happen is on the left side, it's going to cancel out, and on the right side, it's just going to be here, 0.05 minus x. So let's go ahead and rewrite it again. And as we're rewriting, let's go ahead and multiply this out. So let's see, get my calculator. And 0.513 times 0.05 gives you 0.02565, that's this times that, minus 0.513x. Now, we're going to move this, well, actually we're going to keep this one. We're going to move everything on the right side over to the left side. And we're going to do that by subtracting it. So we subtract this whole thing from itself, and it's going to give us a 0. So we have 4x squared minus this whole thing here, and we're going to put the component here with the x first. So because it's a minus of a minus, it's going to become a plus. 0.513x minus that piece right there, 0.02565. And we still keep the equal sign right here, and we said that we took this whole piece here and we subtracted it from itself, and they gave us a 0. So we do actually write the 0, otherwise we don't know what this is, because without an equals, you cannot have an equation. So now you need to solve this whole thing for 0. And that's basically called finding the roots. Now at this point, you either use a quadratic equation or you need to have it built into your calculator. So I just plugged it into my calculator and it gave me two answers. X equals minus 0.166714, and it also gave me x equals 0.03846. Now, we can only use one of these values. Now, which value do we use? So let's look up here. The concentration for NO2 is 2 times x. Well, if we took this concentration here, this negative, and we plugged it in, we'd get a negative concentration. I'm not really sure what that is, so I'm pretty sure that's probably not right. So what I'm going to do is go ahead and write an x through this, and then we're going to take this x and plug it in there. So 2 times x, and we're going to get the concentration of NO2 equals 2x. We know x there, so we basically know 2x. So 2 times x is 0.0770 molar, and we'll look up here, 3 significant digits there, 3 there, 3 there. Looks like it's 3 all over the place. So it's 3 significant digits, and this is good. And we're going to get the concentration of N2O4, N2O4, and that is equal to 0.05 minus x. Take the x from here, plug it in here, and it's going to give you 0.0115 molar. What else is it asking for? If the reaction vessel initially contains this, what are the equilibrium concentrations of this and this at 500 degrees? At 500 Kelvin. Okay, so that's all this was asking for. Here is the answer to the problem.